All right, so this is going to be a quick video of the solution to the study guide. We discussed this one in class. We have a total of 80 students, and whether they play an instrument or not. And we have the females, the males, and these are just the totals of the columns and rows. And they're going to ask you for statements like more females than males play an instrument. Obviously, it's going to be a different table. More females than males play an instrument. So when you look at the females, look at the males. Yes, more females play. This one says that more males play an instrument than females. So we're looking at the ones that play an instrument. So out of the ones that play an instrument, the more males? Nope, it's more females. So that's why the statement is not true. This one says less females don't play an instrument, males. So we're looking at don't play an instrument, and is it less females that don't play an instrument? That is incorrect. It's actually less males that don't play an instrument. That's why I said no, the statement is false. This one says less students play an instrument than those that do not. So now we're looking at the total students that play an instrument. So 6.60 play an instrument, 0.4 don't. Less students play than those that do not play. No, it's actually the backwards argument. So that's why I went with no. More males do not play an instrument out of all the males. So now we're focusing only on the males. So that's these two numbers. And they're saying more males don't play. Once again, it's wrong. 0.19 is less than 0.25. So it is definitely not a true statement. This one, I got to you. It is complicated, but here we go. And so what we have is some students, 11th and 12th graders, went to the zoo, and then they were asked which one was your preferred animal at the zoo. So they had to choose from they chose between lions, zebra, and monkeys. And I did the totals for you guys. So what makes two events independent? Events are independent when the outcomes of one don't affect the other. So for example, flipping a coin and pulling a card from a deck of cards. Event, the student is a 12th grader and the preferred animal is a zebra. Are they independent? True or false? No, the statement is saying that they are independent. So the question is it true or false? So I wrote it right here. The event is that it's a 12th grader. And if you're a 12th grader, it'll be 36 12th graders out of 74 students. And preferred animal is a zebra. So now we're just looking at the zebras. That's 32 out of 74. So the question is, these two are independent. So what would make them independent is if we multiply them and it will equal the overlap, the and probability. Okay? We have these numbers. The probability of being a 12th grader is 36 over 74 times the probability of a zebra, 32 over 74. So the one that we have to calculate now is this one. And that's an and probability, and that happens when the 12th graders and the zebra, so right here, 17 out of 74. All right, and so does this number equal the product of those two numbers? And the answer is no, they do not. So therefore, this probability and that probability are not independent. All right, C. How do we calculate the overlap or the and probability for dependent and independent events? All right, because the formula changes. Right? So if you're independent, it's just the multiplication of the two individual probabilities. But if they are dependent, then it's the probability of A times the probability of B given that A has already occurred. All right, so conditional probability. All right, so a lot of it is kind of choosing which is the correct statement. So let's say, for example, that I say the probability that the student is an 11th grader and that the preferred animal is a monkey is the product of each individual event. So let's write it in notation. The probability that the student is an 11th grader and the preferred animal is a monkey, that's an M, is the product, so it's multiplied, of each individual event. The individual events are the probability that you're an 11th grader times the probability that your preferred animal is a monkey. Well, how do we know if this statement is true or not? Well, we look for numbers. What's the probability of 11th graders and monkey being preferred? Right here, 14 out of 74. All right, question mark, because we don't know. What's the probability of being an 11th grader? 38 out of 74 times the probability of preferred animal being a monkey, 29 out of 74. And so when you look at the left and you look at the right, does this product equal this number? No. So that statement is false. So you want to follow this kind of mentality. Write the product in notation, get the numbers, and then see if it's true or not. Right, and this, I think I eventually did this on a separate piece of paper in that room. So here we go. The probability that the preferred animal is a lion, given that the student is a 12th grader, is equal to the probability that the preferred animal is a lion. Is this statement true or false? Well, first things first, we want to write the notation. The probability that the preferred animal is a lion, given that the student is a 12th grader, is this equal to the probability that the preferred animal is a lion? So we wrote the notation. This one, I don't even think I had to separate it like this, so let me try this. The probability that the preferred animal is a lion, given that you're a 12th grader. So we're only looking at the 12th graders. And the probability the preferred animal is 12, so it's 4 out of 74. And does that equal probability of liking of being a lion, which is 13 out of 74? So the answer would be no if I did it that way. I went the long way, of course. I rewrote this. This is conditional. So this is the probability of both over the probability of being a 12th grader. And then I cross multiplied, right? This times that. So the probability of both, is that equal to lion times the probability of being a 12th graders? And when I multiplied, I got a false statement. This side does not equal that product, so it's false, which is the exact same result from here. Okay, it's false. All right. F. The probability that the preferred animal is a zebra and you're an 11th grader. Okay. So the probability preferred animal zebra and that you're an 11th grader is the same as the product of the preferred probability that your preferred animal is a zebra, probability, and the probability that you are an 11th grader given that your preferred animal is a zebra. Probability that you're 11th grader given preferred animal zebra. So now the question is this statement true? Is when I multiply these two probabilities, does it equal this one? Well, let's find out. Zebra and 11th graders. Right here, 15 out of 74. Probability of zebra, 32 out of 74 times probability that you're an 11th grader given that you like zebras. So we're only looking at the ones that like zebras, and the 11th graders are 15 out of 32. I know it looks like 82, but that's a 32. And look at that. If I multiply these two, I get that 15 over 74 is equal. The 32's cancel, and you're left with 15 over 74. So this statement in E, all of that is a true statement. All right. A rectangular swimming pool has a shallow end and gently slopes from 3 feet. Oh, we said we were going to change this to 4 feet, and another end that is 7 feet. Okay. Swimming pool is completely full of water. It is treated with chlorine to keep it clean. The concentration of chlorine is 85 milligrams per cubic foot. How many grams of chlorine are in the pool? Now they want to know grams, but they gave this to us in milligrams, so we need to be careful. All right. Whew. All right, looking at the diagram in this, zoom out a little bit so I can get both perspectives on screen. All right. So from here to here is 25. This drop right here is 3, and this drop right here is 4, making this a trapezoid. And then it's a prism because it's the same over here. And 65 is how much it extends, okay? So I call that A. Then from here to here, right, 4, and then this is the full drop, so it's 7. 7. It's also another trapezoidal prism. One base is 4, the other base is 7, and the distance between them is 5. I think I forgot to mention that this base is 3, that base is 4, and their distance is 25. All right, and they both have 65 as the height of the prism. All right, and then I call that B. And then the last shape is this easy one, rectangular prism. So this is 7, 7, 20, 20. We only need the 7, 20, and then the prism is 65, has a height of 65. Okay. So this is how you calculate the volume of a trapezoidal prism. This is how you do the area of a trapezoid. 1/2 the sum of the bases times the height difference between the bases. And then times the height of the prisms. The prisms all have a height of 65. All right, so here the two bases are 3 and 4, and the distance between them is 25. So that's why it says 1/2, 3 plus 4, times the 25, and then times the 65. Okay. For this one, the bases are 4 and 7, and their distance is 5, and the height of the prism is 65. So 1/2, 4 plus 7, times 5, times 65. The rectangular prism, 7 times 20 times 65. 9,100. I added these three numbers together and I got this. Now, we know that we have 16,575 cubic feet and that there's 85 milligrams per cubic foot. You see, cubic foot cancels. I'm left with milligrams, but I want to know grams. So then I have to remember that 1,000 milligrams is equal to 1 gram. So since I have milligrams in the numerator, my 1,000 milligrams goes down here, 1 gram goes there, milligrams cancel, and this times that divided by 1,000 gives me this number. And this is how many grams of chlorine we have. Okay. All right, so now we have 4 different ice creams.
What is the ice cream?
Ice cream number 1 has chocolate, cookies and cream, vanilla, and strawberry. Ice cream number 2 has vanilla, cookie dough, and butter pecan. Ice cream number 3 has chocolate, butter pecan, and French vanilla. And the 4th one is salted caramel, which is over here, butter pecan, cookies and cream, and cookie dough. All right, so then the part that I did here is we have 4 ice creams, and what's the probability that they're going to have chocolate? Well, it's going to be 2 out of 4. The probability they'll have cookies and cream, 2 out of 4. Vanilla, 2 out of 4. Strawberry, only 1 out of 4. Cookie dough, 2 out of 4. Butter pecan, 3 out of 4. French vanilla, 1 out of 4. Salted caramel, 1 out of 4. All right, and then we have 4 statements and we need to know whether they're true or false.
Did you spell something there? I haven't seen like this. You remember? But I actually have it already, but
Yeah. All right, so it says here that the probability that the customer chooses an ice cream with butter pecan or salted caramel is 3/4, and that this is represented by this. Okay, so I forgot to state that first, all 4 choices talk about or probability. So this one is going to be the one where we add the probabilities and then subtract any overlap. Okay. So butter pecan. Butter pecan is 3/4 plus salted caramel. Salted caramel is 1/4. Now, is there any overlap between butter pecan and salted caramel? These are butter pecan. This is salted caramel. So yes, in ice cream number 4, there's an overlap. So that's why we're saying minus 1/4. All right, is 3/4. So now when you check, this is represented by 3/4 plus 1/4 minus 1/4. And so this statement is true. Now this one, strawberry. Strawberry is 1/4. Or means plus, we add butter pecan. Butter pecan is 3 out of 4. Now, is there any overlap between strawberry and butter pecan? And the answer is no. There is no overlap. There's only 1 for each ice cream. So that is why we are just going to do 1/4 plus 3/4, which is 4/4, which is equal to 1. Now, they're saying that it can be represented by this. But you can see they have the 1/4, they have the plus 3/4, but then they have a minus 1/4. And that makes this a false statement. Okay, because they're doing it wrong. All right, probability the customer chooses an ice cream with vanilla, which is right here, 2/4, or cookie dough, 2/4. Now, is there any overlap between vanilla and cookie dough? This is vanilla, and this is cookie dough. So you can see that we do have some overlap. We have overlap in ice cream number 2. So we need to subtract 1 out of 4. So this is where this minus 1 out of 4 is. So it's 3 out of 4. Right? And they represent it correctly, so that's why I said that was a true statement. The probability that the customer chooses an ice cream with French vanilla, right here, 1 out of 4, or salted caramel, 1 out of 4. Now, is there any overlap? No, there isn't. This is ice cream 3 and this one's ice cream 4. So we don't need to subtract anything. 2 over 4 is equal to 1/2. And then we look at what they did, and it's true. All right, so please make sure that you know how to do or probability correctly. And remember, when this doesn't make sense, use a grid, okay? All right, equilateral triangles. Equilateral triangles are also equiangular, which means all the angles are 60. The altitude, though, is a perpendicular bisector. And the altitude is what we need in order to calculate area. So the good thing is it splits this bottom part into 2 equal parts. And also it becomes a right triangle, so we can use a squared plus b squared equals c squared. Okay, so this one says find the area. We know it's equilateral because all 3 sides are 8. This is the altitude, which is the height that we need. And we know that it splits this bottom base into 2 equal pieces. So we are going to focus on this. Okay? And so a squared plus b squared equals c squared. A squared is 4 squared. The height we don't know, so it's h squared equals the hypotenuse, which is 8 squared. I'm going to subtract this from both sides. So h squared equals 8 squared minus 4 squared. I'm going to take the square root on both sides. And I'm going to put it in the calculator, and I get 4 radical 3. So that's my height. Now that I have the height, I can calculate the area of the triangle. Area of a triangle is 1/2 base times height. The base is the whole thing, so that's one thing that students mix up. And the height we just calculated, it's 4 radical 3. So 1/2 times 8 times 4 radical 3 is 27.7. All right, so none of this came, it's just the words. Find an area of an equilateral triangle with a side length of 20 centimeters. Lateral triangle. It's perpendicular bisector, so it splits this bottom segment. So this one is 10, the height we don't know, and the hypotenuse is 20. So 10 squared plus h squared equals 20 squared. Okay, I isolate the h squared by subtracting 10 squared from both sides. Take the square root and I get 10 radical 3. And once again, when I do the area calculation, I need to use the full base. So that's why this is 1/2 times the 20 times the 10 radical 3, 173.2. Okay. So this one says to write an expression that represents the area. And so we're going to treat this as a length and a width, which means we multiply them. 3 minus x, 2x positive 5. And make sure you combine your terms correctly and you don't mess up on the signs, because you want to make sure it gets correct. So please make sure that you practice the multiplication before you look at the solutions. Clear? All right, so this one is draw the reflection over the x-axis and the y-axis of a line segment that has these 2 endpoints, 2, 5, and 8, 1. Now, if we're doing a reflection over the x-axis, the quick way to do it on a coordinate plane is to understand that it's going to be equidistant to the line of symmetry. So this is 5 units away from the x-axis, so the reflection is going to be 5 units away. This is 2, 5, the image. All right, same thing here. This is 1 unit away, so the other reflection will be 1 unit away. Prime. Now, if you're going to reflect over the y-axis, then it's the distance to the y-axis. This point is 2 units away, so the reflection will be 2 units away. This point is 8 units away, so the reflection is going to be 8 units away. So this is over the y-axis. And if they ask you for the order pairs, feel free to read them. -2, +5. -8, +1, so on and so forth. I wrote these because I was looking at this and I was just thinking prime, but the correct order paired is 2, -5. And this one is 8, -1. So I'm sorry for the confusion earlier, okay? All right, arc length. Make sure I just this on a piece of paper. So this is your basic formula for the arc length, S equals R times theta. With S being the arc length, the radius is R, the central angle is theta, and this is when we use radians. So you don't really have to worry so much about it, but just so that you know. The radius is 1. What is the arc length when the angle is pi-thirds? So I did that mark right here. The radius is 1. What is the arc length when angle is pi-thirds? Right, so S equals R times theta. S we don't know. 1 times pi-third, S equals pi-thirds. Easy. Number 2, the radius is 13. What is the arc length? So that's why S equals question mark when the angle is pi over 5. Angle pi over 5. S equals R theta. S we don't know. 13 times pi over 5 is this. So that's your arc length. All right. C changes a bit. The radius is 17. The angle, what is the angle when the arc length is pi? So radius 17, what is the angle when the length of the arc is pi? So now notice S equals R theta. For S, I'm going to substitute in the pi. For R, I'm going to substitute in the 17. And for theta, it's going to stay as theta because we don't know what it is. We're solving for it. And remember, don't forget to bring down your equal sign. Now, since I want theta, I need to divide out the 17 from both sides. Okay, it cancels. So theta equals pi divided by 17. Okay. Another exercise. The radius is 5. Arc measures 3 pi over 2. Arc is the arc length. So S equals 3 pi over 2. What is the radian measure of the central angle? So what is theta? Okay. So I write the equation. I substitute the information in the correct place. S is 3 pi over 2 equals 5 times theta. Divide both sides by 5. And you get that theta is 3 pi over 10. All right, I'm going to end the video here at number 9, and then I'll start on number 10 on the next video.